All right, good afternoon, everybody. Welcome to the GPSTEC201, which is building an artificial intelligence practice for consulting partners. My name's Matt McLean. I'm a solutions architect with AWS. I work in our partner organization, helping large system integration partners build their AWS practice. And I'm also a machine learning and artificial intelligence subject matter expert. Going to be joined today by Robert Monroe. So Robert is the VP of Machine Learning at one of our key partners, CrowdFlower. So we're going to have a Antipodean flavored talk today with a Kiwi and an Aussie. So hopefully you'll be able to understand our weird accents. So what you can expect from the session today, I'm just going to kind of level set, go into looking at kind of the promise and the possibilities of machine learning. We're going to look at the machine learning process and really look at the importance of data in terms of getting successful and accurate models. We'll look at some of the possibilities, so the kind of engagements you could look to have with your customers. And then we'll also dig into how you can qualify machine learning opportunities, so the kind of questions you might want to ask your customers to see if machine learning is a good fit for their particular business problem. And then finally, we're going to have Rob is going to go into a couple of topics. So building an AI team. Rob has had a lot of experience with machine learning and building teams, so he's going to pass on some key knowledge in this area, and also the importance of data annotation, and talk a bit about the CrowdFlower platform and how it can help you in your projects. So just before we get started, how many are people working for big data consultancy partners of AWS? All right, quite a few. And how many are actually deploying machine learning models in your customer projects or engagements? Okay, so there's a few. So in order to kind of level set, I think we often get asked by our customers, what can AI do for my company? And I think one quote that kind of sums up really the impact AI can have comes from a professor at Stanford, Andrew Ng. He's also the co-founder of Coursera and has a startup called deeplearning.ai. And he says that AI is the new electricity. And what this kind of means is that if you think just over 100 years ago, electricity wasn't used at all, right? But gradually over time, it was used by every single industry and has really transformed the way that companies work and operate. And really, AI has the similar potential that basically there's no industry where it can't have an impact in terms of, say, automating and changing processes to launching new kinds of services and innovations. So the kind of things that AI can do, probably the most common use case for machine learning, artificial intelligence, is what we call supervised learning. And this is essentially an input-to-output mapping. So you basically feed in the algorithm input data, shown here as A, and the expected outputs for that input data, shown as B. And essentially, the machine learning algorithm will learn this mapping. So you can pass in new data, and it will give you the predicted output labels. Now, this is not something new. This has been around for a long time. So some of the common things you can do with supervised learning are things like analyzing email to see if there's spam. So you can feed in the machine learning algorithm examples of email with spam and without spam, and it will learn to recognize when you pass in new examples. Another example could be loan applications. So, if you're a company, a finance company with data on applicants and users or customers of yours, you can take the features such as things like, say, age, salary, area where they live, etc., and then build a model to understand if people are likely to repay your loan or not. And really, over the last few years, some of the real advances in machine learning and AI have been around sort of unstructured data, so data like images, audio. So you're able to do really groundbreaking sort of things, such as understanding objects that are present in an image, for example, and even surpass human-level performance. Other examples are translating text into audio, and even doing translation itself from one language to another are some of the latest advancements in machine learning and AI that have been produced today. And these advancements, really the kind of the hype around artificial intelligence has come through deep learning, which is almost a rebranding of neural networks, which actually have been around for a while. But deep learning has really taken off because of three key sort of reasons. And the first is data. Because back in, say, the 80s, when researchers were building neural networks, they couldn't have a lot of data. You know, it was expensive to capture and store data. But now with the advent of cloud computing and services that AWS provide, like Amazon S3, you know, companies can store massive amounts of data, you know, petabytes even. And this is one of the key reasons for having these models achieving the really good levels of accuracy. Another reason is algorithms, and this is where the research community is focusing a lot on. So there's been a lot of tweaks and enhancements in terms of the algorithms that are used, especially how these neural networks are initialized and some of the sort of the nonlinear functions that are being applied. And then finally, from a compute point of view, that's something that's really sort of advanced research, and the way that these machine models can be built is the advent of graphical processing units. So these graphical processing units are really good at doing these linear algebra matrix multiplications a lot faster than your sort of standard CPU. So they've been applied in deep learning to really speed up the training of these machine learning models. So, you know, going from, say, weeks down to days and even hours. And as well as applying some high-performance computing architectures. So no longer you need, say, one card or one GPU, you can actually run in fleets of multiple GPUs in an instance or even multiple servers to really speed up the training of these models. So now we'll kind of go into the sort of value creation process for machine learning. And really, it all starts with the data. And this, you know, if there's one key takeaway from the session that you should understand is that, you know, you really need to understand what data your customers have in order to be able to figure out if they can apply machine learning to a particular business problem. So often the data that the customer has is not in a format or is not ready to be applied into a machine learning algorithm. Often you have to do some analytics on it, some pre-processing to cleanse it, to get it into a state where it can be used for training. So you need to do some analytics. And then once you have the data ready, then you're ready to build your products by training your machine learning models to build a new product or service to deploy to your customer. So once you launch your product, you'll get users using and getting benefit of the advanced features that you have. And then this allows you to gather more data and then build more accurate models. So you can see it becomes this virtuous cycle. And really, this is a lot of what the teams, you know, advanced teams do, is they'll focus on building a cycle of data to deploy and build good services for their customers. So if we look at this wheel, there's kind of two key skills that you need to build in your team. So from the analytics point of view, this is applying, you know, big data best practices. And then for the products point of view, is building skills around building machine learning models and deploying them into production. And if we look at the value creation in machine learning, so we've looked at, from an algorithm point of view, supervised learning probably has the most value. So it's often a good place to start. Transfer learning is where you're taking a model that's been trained on a data set. Often, for example, in computer vision, you take a model that's trained on ImageNet, which are millions of images and thousands of categories, and then try and apply that to a new problem, say, such as looking in the medical field, say, looking for cancerous nodule lumps in, for example, lungs. You can often use the pre-trained networks and just fine-tune the network to a different problem. Unsupervised learning and reinforcement learning have a lot of potential. There's a lot of research going into these areas, but probably today providing a bit less value than compared to those other methods. And then from a data point of view, what we see is that companies have a lot of structured data in their existing, say, data warehouses or transactional systems. And these can probably provide the most value or low-hanging fruit to really apply machine learning. So doing things such as fraud detection or forecasting, recommendations on, say, products and services for their customers are good starting points. So now we'll kind of look into the machine learning process, so how it works, and kind of look how it differs from, for example, software engineering life cycles. So it always starts with the business problem. So in Amazon, we use an approach called working backwards, and this is for any service or product that Amazon launches. And it all starts with the team who has the idea writing a press release and a frequently asked questions document to really understand the business problem and put themselves in the shoes of the customer. So this would be, an approach that we would recommend any of you to adopt. So now we kind of get into the specifics of machine learning. In the software development world, you start with the developers maybe coding up a prototype or mocking up some user interfaces. In machine learning, it all starts with the data. So figuring out what data you have and preparing it in a way that it can be ready for the machine learning algorithms to get trained on. So really what we see is data analytics is a foundational part of machine learning and mandatory skill. And this is something that Rob's going to talk to, but most of the work even of data scientists is in preparing the data before it gets passed to these models. So in AWS, we have multiple services to help sort of build a practice around data analytics. One common pattern we see is customers building what we call a data lake and using S3 as sort of their fundamental key storage or area for their data. Or services like Redshift, which is our data warehouse offering. And then for actually processing the data, we have many different services. We see a lot of customers using, for example, Spark on Elastic MapReduce to really do their ETL jobs and process the data and get it into the right state. And we even have a AWS Glue, which is a fairly new service, which is a serverless ETL service that you can run your PySpark jobs to process your data in, say, an S3 or some other data source. So once the data is being processed and prepared, now we move into the actual development. So this is where the data scientists will take the data and then build and train their machine learning models. And here there's the diagram showing the various services that Amazon AI have in the Amazon AI stack, which are really in three parts. We have the frameworks and infrastructure at the bottom. We have the machine learning platforms. And then up the top, we have the API services. Now, the API services are grayed out here because you can't actually build models in that. This is something that AWS does behind the scenes. But for the infrastructure and frameworks and platforms, these are services that allow you to build essentially your machine learning models. So the bottom ones, the infrastructure and frameworks, are really for your expert machine learning practitioners. And typically, they want to have full control over the entire life cycle. They're very familiar with building models, training them, and then deploying them into production. So they want to have full control over all aspects of the life cycle and how these architectures are built. So they'll often want to use specific hardware in order to train their models. And probably the most popular approach is to take the GPU, especially if they're using deep learning. So we have two types of GPU instances. The P2 instance, which uses the NVIDIA K80 GPU cards. And we've just recently released the P3. So this is using the very latest NVIDIA Volta V100 GPU cards. So this is really to accelerate the training of these models. So on top of the base infrastructure, they'll launch the deep learning AMI. So this is an Amazon Machine Image, which comes preloaded with many of the most popular open source deep learning frameworks, such as Apache MXNet, TensorFlow, Keras. And it also comes with all of the NVIDIA drivers preloaded. So it's very easy just to basically spin up the image and start their data science work. And then there are other customers who want more of a managed platform. So also in the case where they have a lot of data and they need multiple servers, they need a platform to basically run their machine learning models. And here, probably a very common use case is to use Spark, Spark on EMR. So an example of this is Netflix. So Netflix, they actually run their recommendations for movies to their customers using Spark on EMR, and they run it over 25 petabytes of data. So really large-scale jobs using Spark on EMR. So finally, once we've trained the models, and we can then deploy. So this is where you're actually deploying it in your actual product or service to your end customers. And this is often what we call machine learning inference, where you're actually then predicting on real data. So here, again, we've got a few different options for our customers for how they can deploy their machine learning models in the cloud. For example, we have often running these machine learning models is quite compute intensive. So we have, for example, the C5 instance, which offers the latest Intel Skylake processors. But there's some customers also want to deploy, at the edge. So it could be in their mobile device or, say, in a drone or in a car. So we have services like Greengrass from our IoT platform, which allows you to essentially run and do your model inference at the edge. So some of the characteristics of companies who, I would say, leading in artificial intelligence and applying artificial intelligence in their business are the following. So first of all, it's around the strategic acquisition of data. So they understand that data is really the key asset that they need to build up in order to be strong in artificial intelligence. So they really almost look at it like a multi-year chess game in order to acquire more and more data, because they see it as a competitive barrier to entry. And an example of this could be Amazon itself. Amazon over the years, over the decades that, a couple of decades that we've been in business from our retail business, have acquired a lot of data on how customers are buying different products. So it's hard for competitors to come in if they don't have that amount of data to provide recommendations, for example, on buying habits and understand customers' buying habits. So another characteristic is to have a centralized data lake, to have data prepared, sort of prepared and pre-processed, to be available for data scientists to do their work. So having for example, using S3 is a great example, S3 and Redshift to store data and be available for data scientists is a good practice. And then automation, so that cycle of machine learning or the machine learning process that we just looked at, it's good practice to automate that as much as possible. So the preparation, the building and training of the models, and then deploying them into production. If you can automate that, then this will help you essentially ensure your models are up to date and launch new products and services quickly to your customers. So now we'll kind of look at some opportunities for you as consulting partners. So the kind of engagements that you could look to have with your customers. So if we start off with some more, say, tactical, so these are sort of projects, if you're not doing machine learning today, that you could think about starting with. So first of all, we've seen that building a data lake is a good practice. So helping your customers build a data lake could be a great starting point. And we have a few resources here to even help you. So for example, we have quick start guides. So this is basically a very detailed architecture along with CloudFormation scripts that you can essentially very quickly spin up and get started. And we even offer a training course, so building a serverless data lake, so you can learn sort of our best practices for doing this. So bring about a quick win on a specific challenge. So getting back to what I mentioned about the high-value algorithms and data, take a supervised learning algorithm with some sort of structured data could be a really good starting point to do something like forecasting or recommendations, which can use the data that a customer has today. So facilitate customer engagement. So we have a group, AWS Professional Services, who do engagements around artificial intelligence for customers. And one thing that they've found successful is to organize sort of an internal hackathon, so taking the customer's internal data and applying that for some use case. So for a large media company, they did that on their customer data to build a recommendation engine in just a few weeks. And then finally, helping automate that machine learning process. So, kind of taking the DevOps best practices and tools to automate the preparation of data, the building of the models, and deploying them is a good way to get started with your customers. So some strategic engagement opportunities, identify some common business problem, and then have some standard sort of statements of work, sort of engagements. So for example, if you have finance companies, you could build up a sort of statement of work or an engagement around, taking the data and applying, say fraud detection for your customers. Building a reference architecture. So an example here, if you want to get into something like, say, autonomous driving, having an architecture that starts with the data, doing the training in the cloud on specific instances, and then deploying to the cars, on, say, a specific architecture at the edge, in the car. So sort of building that complete end-to-end reference architecture is a great way to engage with your customers. And developing artifacts that expedite time to outcome. So again, trying to help that machine learning process. So, figuring out, are there data sets that you could kind of collect on behalf of your customers? Are there models you could maybe train, pre-train, and then help them get started? Are good, kind of things that you could look to build up to kind of sell as a service to your customers. And then providing model governance as a managed service. So, this is one thing that maybe differs as well with traditional software engineering is that, business environments change, contexts change. So these models need to be continually updated in order to be relevant. So, this could be a service that you could think to offer to your customers to essentially, manage that process of continually retraining and deploying these models into production to ensure that they're relevant, up to date for your end customers and offer it like a managed service. Also some sort of more high-level consulting that you could look to do, sort of on the advisory, a little bit less technical. Could be to help your customers come up with a data strategy, right? So figure out how they can acquire more and more data to apply that data into new products and services. So look at the business processes. So see, what are some of the processes that are very manual today that could be automated through the use of machine learning is a great sort of advisory opportunity. And then figure out, what are the new services that the customer could launch based on the data that they have that could be launched, or even new businesses, could be new ventures that could be launched based on machine learning. So now, jumping into some of the sort of how you can qualify, if an opportunity can use machine learning. So first question is the problem domain complex enough to warrant machine learning? So, I've been asked this a few times where customers come and really the problem hasn't really warranted machine learning because it's a simple, can logic be applied? So could the problem be solved, say, through validation of input parameters? Could it be done through sort of simple if-then-else statements? If that's the case, then it's probably not complex enough to warrant or applied machine learning. So another example of seeing if machine learning could be applied could be if the problem, a 5-year-old could figure it out, but very hard to codify in logic, say with if-then-else statements, then this is probably could be a good case for using machine learning. So some of these are the classic use cases that we're seeing where machine learning is being successfully applied. Obviously in image recognition, this is very popular and actually now achieving state-of-the-art, even better than human level performance. Spam filters for email, that's been out for a long time. Probably the most lucrative area probably today is online advertising. So this is where the advertisers decide, based on a user that's coming to a particular website, what is the possibility or probability that a user will click on a certain ad. So deciding which ad to present to that user is, basically is driven through machine learning. Fraud detection, very common use case, recommendations, and then speech recognition. Also, another question you want to ask is, is there an API service available for my problem where I don't need to actually build and manage the machine learning model? So here we're showing the Amazon AI API services. So these are really, in typical AWS fashion, taking away the undifferentiated heavy lifting of doing a particular task. So for these three services, we, AWS, manage and train the models and then deploy them for you, so you don't need to. And essentially just interact through the service through a simple API. So for example, for recognition, it can do things such as recognize, give it an image and it'll tell you what are the objects in that particular image. New feature just launched, it can do text recognition from an image. It can also do facial analysis and basically compare faces you've uploaded to new faces and see what the match is. So these are sort of use cases which, if you have a problem and it can be, you can apply the service to it, then it's probably a good place to start because you don't need to then manage those models. Poly, so it does lifelike speech, so text-to-speech, multiple languages, and then Amazon Lex, which provides that automatic natural language processing and understanding. So you can build conversational bots. So if your problem, so this would almost be if you have a visual kind of problem, look at these services, see if they can be applied, and that will accelerate your time to deliver a service. So next question is, does the customer have enough clean data? Because we've seen, data is so important, right, to getting the levels of accuracy of these models. So also temperature. So as we said, business contexts change. So you often need to see how fresh is the data that the customers have. If they have data from years back, it may not be relevant, right, for their particular problem. So having fresh data is often important. Having clean and uniform data. The old garbage in, garbage out adage comes here. So that's often something you need to look, and you may need to spend a lot of time cleaning up the data before it can, you can pass to the data scientists to train their models. And also for deep learning, often you need a lot of data. If you can, in some cases, thousands of examples are necessary rather than just, say, a few hundred or tens. So, that's something to consider as well. And not only the data, but also has to be labeled. And that's actually the next point, is that if you're applying supervised learning for your particular problem, you don't only need the data, but you also need the associated labels, or what is the expected output. And if you have hundreds of thousands, then this can become quite expensive to produce. So Rob's going to go into details on actually how CrowdFlower, how their platform can actually help in annotating your data and getting the labels needed to train your models. And then finally, is there an allowance of error in your model predictions? Because essentially all models are wrong, but some are useful. This is a quote, right? So machine learning is never 100% accurate. You're always going to have some percentage of error in the predictions of your models, because they're essentially trying to generalize something based on limited input data that you provided. So if your problem domain has basically zero tolerance for error, then it's really not a good use case to apply machine learning, right? You always have to have some tolerance of error there. So that's the end of my part. We'll get Rob to come up, and he'll talk about how you can build an AI team and how you can apply data annotation.
All right, thank you, Matt. And thank you, everyone, for staying with us in the last half of the last session on the first day. I think, like me, a lot of you probably were on delayed flights that got in last night, so we thank you for your continued attention. Where is the... All right, thank you. So I'm going to talk about two things today. The first is building an AI team, and in particular, how this might differ from other technical teams that you have built in the past. And also data annotation. So how do we create the training data that's required to train our AI models and to continually update that data so they get smarter. So data scientists or machine learning scientists, as you'll see more commonly known, nowadays are fundamentally problem solvers. There are people who see a problem that one of your customers will have, and they'll come up with a lot of really interesting and innovative solutions to that product. And so as you're building a team, you need to understand how to motivate people who are coming at problems like problem solvers. And so the most important thing is to have a diverse team. So it's been shown many times, diverse teams solve problems much better than individuals or non-diverse teams. So this isn't just something where we want to have as diverse a workforce as possible. It's demonstrably more effective to have a diverse workforce solving this problem. And this will also help you recruit. Good machine learning scientists will be more attracted to coming to work within a diverse team. The second point, oh, did I not jump forward here? Here I am, okay. The second is solving interesting problems. Interesting can mean a number of different things for a data scientist. It could mean interesting problem in the real world, like you're helping with health or with disaster response, or it could be a particularly complicated problem, like rendering 3D images out of multiple still photographs. These are the kind of things which will motivate someone to come and work for you and stay in that position. Finally, sharing your team's science is really important for data scientists, much more than you would have seen for engineers in the past. And this is why we're seeing a lot of companies that haven't taken part in academic publications before, like Facebook and Apple, are all of a sudden presenting dozens of papers at academic conferences on machine learning. It's so that internally, their data scientists can feel like they're contributing to the broader science of their field. So understanding what's going to motivate to get scientists in the door, it's also interesting to think about what do they work on all day, and how can you plan the workload of your data scientists accordingly. So this is from a survey that our company published a year ago. What do data scientists do? And one of the key takeaways here is that most machine learning scientists spent their PhD studying only algorithms. How can we change these algorithms to get like a 2, 3, 4% increase in accuracy? 5% increase in accuracy from an algorithm is like a best paper award at an academic conference. However, in industry, they only spend about 4% of their time working on this particular problem of manipulating the algorithms or the architectures of their deep learning models in order to improve the overall accuracy of their system. They spend most of their time cleaning and organizing data. And so this has often led to data scientists being called data janitors rather than data scientists. It is by far the most labor-intensive task and the most time-consuming that machine learning scientists will spend their time on. And so when organized in a team, you want to keep everyone happy by making sure that the division of labor is something where those small wins, those 5% of the time building models, which is the fun part, that's something that's shared by everybody in the team. So it's not just the one mathematician who gets to think about the deep learning architecture. The whole team should be able to own the process of designing the actual AI component, even if ultimately that's only going to be about 5% of what they spend their time on. Also, it means that you want to think about where you can outsource the components which are going to be the least fun for your in-house data scientists, and that's going to be the data management and the data cleaning. Taking these details into account, when you're building a team, you can think about what are they going to be spending their time on, and therefore what skills am I looking for when I'm putting this team together. So a team is going to spend 50% of its time on data management, designing annotation strategies for training data. So someone who comes from a background with ETL, someone who comes from a background as a data scientist, a corpus manager if they're working with linguistic data, or manager of like large volumes of data. That's the person that's going to be able to make sure that you're managing your data pipeline in a way that you can effectively build machine learning algorithms, and that's what people are going to be spending most of their time on. Sometimes basic scripted ETL, sometimes using much more sophisticated tools in order to transform and annotate data. 20% will be working at how to deploy models at scale. This is another really, really important point. Most machine learning scientists will not know much about DevOps. However, while in the academic world, we concentrate on building machine learning models and testing their accuracy, In deployment, it might be as important that you can get sub-millisecond response from your model than it is to have 1 or 2 increase in accuracy, 1 or 2% increase in accuracy. And so this is an area where you really want somebody with engineering skills rather than necessarily machine learning skills. And so perhaps that's a unicorn on your team who has both these skills. More commonly, you're looking to bring people who both have full stack engineering backgrounds and machine learning backgrounds into a team. Fortunately, at the moment, it's not at all hard to find an engineer who wants to get into machine learning. So this is probably the easiest kind of position to recruit for in an AI team right now. 20% I like to think of as product engineering. So let's think about how you're adapting your machine learning models for your particular domain and problem. Do you care about latency? Do you care about the number of predictions that you can make in parallel? Are you trying to optimize for human feedback or a fully automated system? So how are you taking this machine learning model and productizing it for the particular use case? And then the last 10% is advances in math and theoretical machine learning. And so one of the biggest mistakes I've seen is that the first hire people will make on an AI team is someone who is an absolute rock star at theoretical artificial intelligence. They know how to build the algorithms, they know the math, they can improve on those algorithms, but they don't have these other requisite set of skills. So certainly that's a useful person to have on a team, but this should maybe be your 10th hire for an artificial intelligence team rather than your first. Okay, so that's what to look for when building a team. And now I'm going to talk about data annotation. So preparing your data for AI. And so this is something that's going to make up about 50% of the resources that your AI teams are going to be putting into building effective AI models. I'll talk about 3 components here. How important is training data? How do we get training data? And then how do we combine human and machine intelligence? So how do we get that human-in-the-loop processing such that our AI models can keep getting more accurate over time after they're deployed? So the importance of training data is something that's well known, and it goes back to at least 2001 with this seminal study by Benko and Brill looking at increases amount of training data. In this case, it was predicting what word would occur in the middle of a sentence, like a close task, comparing different algorithms. So these algorithms are a little bit dated here. Naive Bayes is still around as a dateline. Perceptron, this was like a precursor to some of the more sophisticated deep learning models we see today. The same graph still applies. So you can see that while different algorithms are a few % more accurate than each other, given the amount of training data, the amount of training data itself is ultimately more important. And you'll see this a lot of the time as well. So you might spend a year tweaking an algorithm to get a 10% increase in accuracy, whereas you could have spent 10 minutes just annotating additional data to train your AI system for and to get that same increase in accuracy. And we see this being accelerated with deep learning. So again, credit to Andrew Ng, who was running the AI lab at Stanford when I was doing my PhD there. The way that deep learning is differentiated from older, previously more popular forms of machine learning is that it keeps getting accurate when some of these other methods tend to plateau. It might even be less accurate to begin with, and so this can inform your decision about what is the right kind of algorithm to deploy, depending on how much data you have. So with the advent of deep learning, the importance of having large volumes of good training data is actually increased, even though the amount that can be automated has also increased. So the hard thing about starting with this problem of needing more data is that the cost of compute halves every 18 months, right, with Moore's law. So the automated part of deploying an AI model is getting much, much cheaper as the price of hardware gets cheaper. However, the cost of humans to manually create that training data is continually rising as average salaries rise. And so this is becoming a bigger and bigger piece of everyone's spend on artificial intelligence. So I'll tell you about some of the places that training data comes from. And some of you might have seen this comic a couple of weeks ago from XKCD. So it's kind of funny, and that's actually true. So certainly no one is using catch bars for self-driving cars in real time, or at least I hope not. But if you've ever filled out a recaptcha to enter a website and you've transliterated 2 pieces of text within images, one of those was actually you training an AI model That first piece was just to test you and let you into that page to prove that you're not a robot. That second was you actually completing a transcription task on an ancient scanned text. So the AI models can become better at automating that process. So if you've ever used Recatch-Per, you have helped train AI models for a transcription. And this kind of model is one way that workforces come from. There's a lot more which you can think about. So you can think of that kind of work as a crowdsourced worker, right? It's someone anonymous on the internet. They're doing a task. You don't know who they are. They don't really know what your end use case is. You can do simple work. It can be very scalable. However, at CrowdFlower, we think about different kinds of workers that we could let our customers deploy depending on what they're trying to look for in terms of the scalability or the reliability and sophistication of individual workforces. So these contributors could be a crowdsourced workforce. That could be a trusted worker. So we have people who have worked on the CrowdFlower platform for years and years at a time. And so we know how accurate these contributors have been on average in the past, and we can trust them, especially for certain kinds of tasks. We also think about what we call NDA contributors. So these are workforces who are often like BPOs. It's groups of people who sit in a room together. You can train them directly. They can sign an NDA for yourself or for your customer, and therefore they can look at more sensitive data. And then a lot of our customers use this purely for with their own in-house workforce. So some of our largest customers at CrowdFlower have their own analysts who have the skill set and ability to see sensitive data that they wouldn't want to send to an external workforce. But nonetheless, they still want to ensure that they have the same quality of that training data that they ultimately use to train their models. And so, I'll just go back slightly. And so you can actually look here in this graphic. So this is an example of someone doing an image classification task on CrowdFlower. I'm not sure you can quite see it there. These are different workforces that they've used. So we have 100 or so different contributor channels, so different workforces that you can engage in the CrowdFlower platform. And in this analytics page, someone can see the accuracy of the workforces in those different channels. And so this would let one of our customers maybe run a pilot, look at which of these channels were the most accurate, had the best throughput for their particular task, and then zero in on that particular workforce for future tasks. And so ensuring data quality, I'm going to talk about 3 ways, which are really common ways that you should ensure data quality. This could be something that you would do internally yourself, or it could be with a third-party vendor, and I'll use examples from CrowdFlower. So after selecting the right workforce, you also want to think about ensuring the quality of a worker by embedding gold examples. So in data annotation parlance, gold example is something you already know the answer to. So is this picture of a stop sign? You already know that there's a stop sign in there. By having a number of these pre-labeled but hidden examples, you can do one of 2 things. You can run initial quizzes. So somebody has to get a certain % of accuracy on this task before they're permitted to do it. And then you can also continually embed these known answers throughout the task so that you can track this person's accuracy throughout the entire task. And then you can make the decision about what level of accuracy should someone still remain in the task for creating the annotations for your training data. And play around with those for what ultimately results in better models for your end use case. Then the third is giving multiple people one task and calculate an agreement. And the mathematics on this is actually fairly simple. So imagine you need 99% accuracy, but you know the average human is only 90% accuracy. Well, if you give the same task to multiple people, and all else being equal, 2 people agree with the result, and you know that both 90% accurate, then the chance that that result is going to be correct is actually 99%. If you have 3 people agree, it becomes 99.9%. So you can look for agreement between multiple workers and get a high level of accuracy than any one human individual can get. And this has been shown from very simple domains like image recognition, all the way through to more complicated things where untrained crowdsourced workers with the right quality control can beat trained medical professionals individually in doing things like identifying cancerous cells. So it can be a really effective way of scaling tasks that you might have thought were otherwise beyond the capabilities of individual workers. And here's an example of calculating agreement. So once you have multiple workers, do you look at the combination of their agreement? Do you go with the one you trusted most? That'll be context specific as well. And so seriously think, how many people create training data each day? So hundreds of thousands of people every day are doing these tasks. They are annotating data. So here's an example of one of our contributor channels where there's rooms full of people sitting down and annotating data. So there are far more people employed annotating data in AI than in any other part of the AI ecosystem, although these are ones you don't hear about very much. And what a task looks like, you're really just training the AI to see the world in the way that it needs to for your task. So this would be the result of a semantic segmentation task. A contributor has sat down, they've been told to apply these different colors to the different items in this case, autonomous vehicle image. So paint the trees this way, the street this way, cars this way, pedestrians this way. And this is all the input that an AI algorithm then needs, that it can learn from tens of thousands of these such images within videos, and then that is enough for the autonomous vehicle to recognize these objects as it's moving and stay in the lane or avoid the objects appropriately. So where this fits in, active learning, human-in-the-loop processing. So imagine you've annotated your data, you've deployed your model, you want to keep learning from this model. So with the self-driving car example, you're still collecting videos as your car is driving all around the different neighborhoods all around the world, but you can't put those billions and billions of frames of images all in front of humans for review. So you have to be strategic about what are those right images to put in front of humans for review so that you can update those machine learning models. And this process is known as active learning. So it's how you're combining human processing and machine learning in order to automate a task to get the highest level of accuracy as quickly as possible. So a great example here that we've built out on the AWS ecosystem is with Giphy. So if you've ever shared a GIF on Facebook or iPhone or Twitter or on Slack, you've probably used Giphy. They're embedded in all those devices. They are the main purveyors of online GIFs. So they are the best and the worst of the internet, including obviously this famous picture of Shaq and Cat. And so they face a problem where they're getting millions and millions of GIFs shared, but they don't want a GIF that is explicit to end up on the iPhone of a 15-year-old. So the problem that the CrowdFlower is taking on here is our contributor workforce rating these like movies, right? Is this rated G, PG, PG-13, R, or explicit? And so with these millions of images that we are manually processing with them per month, we can then now help them scale to tens of millions of images by building machine learning models on those which have seen the human labels. Does anyone want to guess what this actual rating for this should be? It's actually just G, it's not PG. Yeah, despite that face. Yeah. So the architecture is fairly simple here. So Giphy have these millions of high-value GIFs. So they're from sources that they already view to be high value, and these all get a human rating. Every single one of these, before it ends up on anyone's phone or device, has had multiple humans look at the confidence calculated and the appropriate rating given. Then using these, we're able to build out a machine learning platform that can take an image and make its own prediction with a certain level of confidence about whether some new image happens to be any one of these particular labels. What's fun in this use case as well is that it also allows us to pull out the keyframes. So you can imagine, because it's the internet, that you might find a nice Disney GIF, and someone has put one scene from a horror movie as one frame in the middle of one of those GIFs. So the machine learning can also see that frame, whereas a human might miss it, and our model is able to identify that, and even just for the human task, make sure that that human has seen all the very different frames. So it improves both the human annotation as well as letting them scale to higher volume. And we're using a number of different Amazon AI and AWS services for this. So in CrowdFlower, we make use of RDS and S3 in order to manage large amounts of client detail at scale. And then the machine learning model is built using Keras in the deep learning army that Matt was talking about earlier. And then AWS Lambda, which is a serverless architecture that allows us to deploy and make predictions for a very, very large number of images in parallel really, really quickly. And this is a common model that we are able to use across a large number of clients and use cases. One important extension of what we're doing here is what you heard about earlier is transfer learning. One of the almost magical things to fall out of deep learning advances is that you can take a model trained on one kind of image recognition and adapt it really easily to do something else. So ImageNet is a database of a million everyday images classified to 1,000 different classes. However, people have been really successful in adapting this to do medical imaging or satellite imagery. And the basic takeaway of transfer learning, of one of two ways to do it, is that you have these architectures, these deep learning architectures, where each layer can just be thought of as an abstraction from individual pixels to the actual images. So I don't know to what extent you can see that up here. It's the first layer of your deep learning model. It's really just like textures and edges. You start to see things that might be like objects in the middle layer. In the final layer of the model, if you look closely, you can see things which look like torsos in the bottom middle, things which are pumpkin or pumpkin-shaped to the left of that. And so your deep learning architecture has learned these different textures. It learns these objects and parts of objects. And what that means is that it's fairly easy to adapt it from one use case to another, because these kinds of edges and textures could occur in medical imaging as much as they occur in everyday objects. So one way that you can do transfer learning is you simply take the output from one classifier and put it into another. So you're doing medical imaging, you just take what the ImageNet prediction is and use that output. Another is you can take the deep learning model and retrain just the last layer or a few layers. So you're taking advantage of the millions of images which have learned these textures and these edges, and maybe just with a few thousand newly labeled images, you're able to retrain your model for a completely new task. And there's been lots of great academic papers showing that this is often as effective as manually labeling 10x or even 100x images and starting from scratch. So this is a great way that you can start to deploy models really, really quickly with a small amount of data, and then iterate with active learning to increase your accuracy as quickly as possible. So this kind of architecture is something that we're doing at CrowdFlower for a really wide range of use cases. In some cases with Giphy, we're building and hosting out the machine learning services. More commonly, our customers are doing this. So they're in somewhere like their own AWS environment, which is where they have their machine learning models that they can deploy. And so it's for use cases like self-driving cars, so agriculture, determining good food from bad food as it moves on a conveyor belt, disaster response, which actually my background, I was working in disaster response, and that's what got me motivated to study AI and learn how we can process information when it's needed most at scale. Search, so for use cases like image matching. If you've ever done an image-based search online, there's a good chance that that's powered by this kind of deep learning and maybe by CrowdFlower. Chatbots, so every time you speak to a chatbot, there's probably an active learning behind that for translating your speech into text and for understanding the intent of what command or question you were saying. And lots of use cases in retail as well. So pointing a camera at a shelf and automatically determining how many objects are on a shelf. So something that previously would take a long time for a stockkeeper is now something that can be done really, really quickly with this kind of active learning loop. And so these are just some of what I think are a really large number of potential use cases where it's now viable to go out and help our customers automate or semi-automate a lot of really key business processes. All right, thank you.